So right now we'll be looking at physical standby configuration, but before starting all the configuration steps, let me tell you, we'll be using our production server and we'll be configuring a physical standby for our production server itself. And also over here we are not creating any new server for the standby server. We are using the same our development server to configure a standby on the dev server itself. Let us look at how the configuration will look at the end. Our primary database is ProdDB. Our standby database it is also ProdDB, but you have a DB unique name ProdDB underscore STB, and for ProdDB the DB unique name would be ProdDB only. Do not worry what is this unique name and what is this database name, we'll discuss it in some time. Just understand this is the way to distinguish both primary and standby. The primary database is ProdDB and standby database is ProdDB underscore STB. The servers on which we are configuring is, this is our prod server, and for the standby we are not creating any new virtual machine. What we are doing is on our dev server we will be configuring the standby database. Because I mean, if you have more bandwidth and if you can create new virtual machine, well and good, but in our case we are just trying to keep things simple, like we are not introducing a new server for this configuration. Now there are some changes that you need to do on the production server, and once these changes are done, then you proceed with other steps of physical standby configuration. The physical standby configuration involves multiple steps and stages. We have to make some changes on production. We then have to create a copy of production server onto the dev server, and then we need to start the log apply service. We need to start the log shipping services. We need to check and confirm whether our data guard setup is perfectly fine or not, and we need to also learn about how to start up and shut down a data guard configuration. There are many steps, there are many stages. We will go through each and every stage one by one. The current stage that we are looking at is what are the changes that we need to make on the production side. Also, while we are looking at each and every step, there will be some new terms and there will be some new parameters that you will learn in data guard configuration. Right now I won't start talking about all the parameters first. What we will do is, while we are performing the configuration, we will discuss about each and every new parameter that we find. And let us start with the production server and see what are the changes that we need to make on the production server. First of all, by default, we all know that our production server must run in archive log mode only. Right. Let us connect to our production server and check whether our production server is running in archive log mode or not. Okay, so ps-ef grep pmon. Pmon is up and running. We'll connect to the database. Select name comma open underscore mode from $database. We have ProdDB and it is in read write mode. Let us check whether archive log mode is enabled or not. Yes, we see that archive log mode is enabled. Perfect. So step 1 completed on prod server. Now if it is not in archive log mode, you can use below commands. Definitely right now we don't need all these commands. Let us move on. Enable force login. Now what is this force logging? On the prod server, some users can issue a command like update salary, whatever the employee salary they want to update, with no logging clause. Now what this no logging clause will do is it will update the table, but it will not generate any redo. Now if no redo is generated, then the transaction will not be applied onto the DR server. Just to make sure, what we are saying that okay, on production, even if somebody specifies no logging, clause in any SQL query, still it has to be forcefully logged into redo logs. Still the transaction should be recorded. This is very important. Of course, not many people run the no logging clause in SQL queries, but still you must make sure that it is enabled. First of all, we will check whether the force logging is already enabled or not. We'll use this command. It says force logging is not enabled right now. Let us enable this force logging. Alter database force logging. What this command will do is, even if somebody specifies no login clause in their SQL query, still the transaction will be logged into your redo logs. Fine, we have completed the second step. Next, standby file management parameter. When you create a new table space or when you add a new data file into your production server, the same create tablespace command goes on to your standby server. Over there, do you want to specify the location of data file manually, or do you want that data guard should take care of it automatically? We will always set it to auto because we know that the most important recommendation in data guard is your file system must be exactly same. When your file system is exactly same on both production and the standby server, then definitely you don't need to manually manage the files. Let DataGuard automatically manage the files. So basically all the files that you add on the production will be added in the same path onto the standby server. And that's why you have to set this parameter called as standby file management. It is auto. Auto means you are saying DataGuard that, okay boss, whatever file that I add onto the production server, add the same file into the same location, into the same file system onto the DR server automatically. As a DBA, you won't interfere into the file management. Okay, one secret, it is always set to auto. Nobody wants to take more headache, like they want to come in between and they want to change the locations manually. So always people will set it to auto. Let us make this change on primary. Alter system set standby file management auto. Let us cross verify show parameter standby file management. It is set to auto. The next one is add same number of standby log file as redo log files and groups. Now there is new concept, standby log files. What are these standby log files? Why do we need these standby log files? And what is the benefits of these standby log files? Let us understand the standby log files first, and then we will get into the creation of standby log files. In a data guard configuration, we know that there are multiple types of data guards and multiple types of standby databases, and also in our upcoming lessons you will learn about different protection modes also. First of all, let us look at how the data guard configuration works. Till now we have understand that from the production we have all the logs that are generated, they will be prod.db, they'll be applied onto standby. The logs will be shipped and logs will be applied onto the standby. Great. But what are these logs? Are these redo logs or are these archive logs which get shipped from the production to standby? Remember, in a default configuration, the logs that get shipped from production to standby is archive logs. But we can even configure our data guard configuration saying that directly transfer the redo logs. Do not wait for the archive log to be generated and then shipped. This is called as log real time log apply. this leads to, once again, two concepts. First concept is how real-time log apply work, and then we'll have to also understand how archive apply will work. In real-time log apply, the production server is having all the redo logs that are generated. Remember, these are redo logs, not archives. And these are the archive files that are generated, archives. We have the standby server. These redo logs will be directly written to the redo logs of your standby. These are redo logs. Now, okay, real-time redo log apply is going on. On the production, a transaction is executed. Transaction is recorded into your redo log. The transaction is immediately written directly from your redo log to the redo log of your standby. Fine. Till here everything looks fine. But we have the redo logs on standby. We have the redo logs on the primary. Then why do we need a separate category of redo logs called as standby redo logs? Okay. First thing, what is the drawback if this kind of configuration is there? What is the drawback if directly the primary redo logs are being written to the redo logs of your standby? Remember, if you have transactions that are there in your redo logs which are not yet applied onto your standby, and suddenly you want to open your standby DB, or you want to convert your physical standby to active data guard, then your active data guard has transactions that are applied in the background, but you can still run your queries. All the queries are nothing but the select queries that you can run. The transactions that are running in the background, these transactions, remember, if you open your standby, the standby database will start overwriting the data inside the redo log files, which means whatever redo data that you are getting from the production, it will be overwritten, and this will be a collision of transactions, because your real-time redo data directly coming from primary is written to redo logs of your standby, and you have also activated the standby database saying that okay, this is active standby, or maybe a logical standby, any type of standby that you convert. Once you open your standby, it needs dedicated redo logs, right? Because whatever transactions that happen once you open your standby, it needs to write into some type of redo logs or dedicated redo log files. Now this is the reason why all the transactions that happen on the primary, they are not written to the live redo logs onto the standby. They are directly written onto the standby redo log files. So let us look at the configuration once again. User execute the queries on primary. The transaction is recorded into redo log file. The transaction is written onto the standby redo log files and then applied to the standby database. Perfect. And also let's take you open your standby database. It will continue to write all the transactions into the dedicated redo logs that are available. So let us understand concept once again. You have primary, you have standby. This is your redo log of your standby. This is your redo log of primary, standby. Now you also have another set of redo log files that are called as standby redo logs. Similarly, we also have the standby redo log files on primary. We'll understand why we have standby redo log files on primary in some time. For now, understand user issued query 1. Query 1 is recorded into the redo log file, and from this redo log file the transaction goes into the standby of your standby server, nothing but your standby redo log files, and from the standby redo log files it is applied to the standby database. This is the general configuration. User issues second query, it is recorded onto your redo log files. The transaction goes from this redo log file to your standby redo logs onto the standby server, and then it is applied to your standby database. This is how the general configuration looks. Now, this configuration does not depend on the type of data guard you have. For example, if it is physical standby, it will be in mount mode. If it is in mount mode, definitely there won't be any transactions and there won't be any redo that is generated with the user transactions, right? Your redo logs will be empty. We are not bothered whether the redo logs are empty or they are being written, because our standby redo logs are there to apply all the transactions that are coming from the primary to standby. Now if we change from primary standby to logical standby, which will be in open mode, what happens in logical standby? Users are allowed to issue commands, or users are allowed to perform transactions onto the standby. Now when users are performing transactions, definitely they will generate some redo data. That redo data will be written to the local redo log files of your standby server. And simultaneously, let's take another user issued one query on primary, recorded on redo log files, and this transaction from the redo log file will be transferred to your standby redo log files, and still it is being applied in the background. Now with this configuration, it is not at all dependent on what type of data guard you are using. Your standby redo log files are still activated to write all the transactions that are received from production to your standby. Remember, this configuration will work only when you enable real-time redo apply. Fine. Right now we are not going with real-time redo apply, but we are only understanding what are standby redo log files. Okay. Now coming back to our first question. Fine, we have standby redo logs on my standby server, but why do I need standby redo log files on my production server? Remember, when you perform a switchover, your primary is converted to standby and your standby is converted to primary. In such cases, if your standby is now new primary, whatever transactions that happen onto your new primary, these transactions should be returned to your new standby server standby redo log files, and then it is applied to your new standby server. So whenever the roles will change, you need to make sure that configuration remains exactly same even if you revert your configuration. Remember, let's take you perform a switchover and you have real-time redo log apply enabled and you did not configure standby redo log files on primary. What will happen? The redos from your standby will not be able to transfer onto your new standby server, and your new standby server will have gap. And again, to resolve this gap, you will have to manually interfere. So this is about standby redo log files and what is the importance of standby redo log files. Now when we talk about standby redo log files, remember, Oracle recommends it to be enabled only when you go with real-time redo apply. But what I say is, blindly when you are configuring any data guard, any type of data guard, you just enable and create your standby log files. So tomorrow when you are switching from archive apply to real-time redo apply, you don't need to come back and once again check your configuration. It will not add up much complexity. You just need to add few redo log files and done. So in future, if your client says that, okay boss, I don't want archive apply, I want real-time redo apply, then you just need to convert from your archive apply to your redo apply the configuration. Okay, this is about real-time redo log apply. Let us look at how archive log apply works in DataGuard configuration. The configuration that we will be looking at, it will be archive log apply configuration. What happens in archive log apply configuration is we have primary and we have standby. On primary, we have archive destination 1, and we know that how many destination we can have? 30. We can have 30 archive destinations, and all these archive destinations can be used to configure a DataGuard. What we do is we say that archive destination 2 is equal to, we give the destination of the standby server archive location. What happens whenever on primary there is an archive that is generated, this archive will be definitely generated into your archive destination 1, and also this archive will be returned to the archive destination 2, whatever location you specify onto the standby server. And on the standby server, when you receive your archive log, it is applied onto your standby server. From the archive destination, the archives will be applied to your standby server. Now there is no intervention of your redo logs. In such configuration, when you are using archive log apply, even if you do not create the standby redo log files, it is okay. But as I said, tomorrow if client says to convert from archive log apply to real-time redo log apply, you will again have to perform some modifications. So to avoid those modifications and to recheck all your DataGuard configuration, what you can do is you can create standby redo log files right away. So tomorrow you don't have a problem. So the next step that we have is add same number of standby log files as redo log files or groups on the production server. First of all, what we need to do is we need to check the current log file groups and add current +1 standby log groups. Remember, you can add the same number of log file group as your redo log groups, but it is always recommended to add one extra group into your standby redo log files. First of all, let us check what are the existing redo log groups and redo log files onto the primary server. So we have this command select group number member from $log file. We are only checking the number of redo log files. We see that there are 3 redo log file group and we have only one single member into each group. Always Oracle recommends you should have minimum 2 groups and minimum 2 redo log members in each group. Definitely we are going with default configuration, so right now we are not bothered about it, but make sure in real time you have at least 2 members in each group. Fine. The command to add a standby log file is alter database and add standby log file group. Now this group number, what group number you should give? Just to differentiate and make your life easy, what you do is always give group number which is apart from the normal series. For example, if you have like 1 to 5 redo log groups, try to give the redo log groups like 11 to 15. And if you have redo log groups from 1 to 10 or 1 to 15, then try to give numbers from 21 to 35. So it's like always add 10 to the numbers and then give the group number. In our case, we have only 3 redo log groups. What we are doing is we are adding 4 standby log file group, and that's why the number will start from 11, 12, 13 and 14. Alter database add standby log file group 11 and give the redo log file name. And the size is 50 MB because our default size of our redo log file when you create a database is 50 MB. We are going with the same size. Remember, the standby log file size must be same as your redo log file size. Do not give a different size. Let us add the first standby log file. We see that the first standby log file group 11 is added. Let us add the second one, nothing but group 12. Enter. The locations of your standby redo log files, you can give a different location, but what we did is we have kept all the standby redo log files in the same location as our normal redo log files. Add the standby log file group 13 and add the last one, standby log file group 14. Once again, check all your group numbers and members from $log file and see whether standby log file group reflecting or not. We can see that we have three normal groups, 1, 2, 3, and we have 11, 12, 13 and 14. As I said, you can go with the same number of standby log file group as your normal log file group, but it is recommended to have one extra group. Right. Next is we need to create a password file for standby database. Remember, password file is for remote authentication, and without password file, it will always be a problem to authenticate both your standby and the production servers. So password file is kind of an encryption that helps both the databases. Okay, I know this database and I can talk to it. Now, before creating the password file, what we need to do is we need to check whether this parameter remote login password file is set to exclusive or not. First, let us check this parameter, and if it is not set to exclusive, then we will use this command alter system set to change the parameter. Show parameter remote login password file. We see that this parameter is already in exclusive mode. We don't need to change this parameter. And in case if you change this parameter, remember you need to restart your database. And now what we will do is we will generate our password file for production DB. Let us do that. So how do we generate our password file? We'll use Aura PWD utility, Aura PWD file equal to, file will be generated under Oracle Home DBS location Aura PW prod DB, and password equal to sys. You need to give the sys password, and I'm mentioning force equal to y in case if password file already exists, it will override the existing password file. Let us go to the location Oracle Home DBS and check whether the new password file is generated or not. We see that Aura PW prod DB is generated. Great. Next, we need to check DB unique name parameter on primary. Now, before even understanding and checking this DB unique name parameter, we have to know what is this unique name parameter and what special importance it has in data guard configuration. First of all, we need to know one thing. I'll take you guys back to cloning. In cloning, we remember we had this prod DB, and when we shipped all the backup pieces of prod DB onto the dev server and tried to perform the restore, we have fooled RMAN by creating a dummy instance of prod DB itself. Why? Why did we do this? Because if you want to restore from RMAN, if you want to use RMAN and restore using RMAN, it will restore to the same database instance ID from which you have taken the backup. You cannot use the ProdDB backup piece to restore it onto a different name until you fool RMAN by creating a dummy instance of same SID with which you have taken the backup. Perfect. This is what we learned in cloning. Similarly, let's take you have your primary and you have your standby. On primary, you have all the clients connecting to primary database. There is some natural disaster and you move all your clients from primary to your standby server. But on the standby server, the database SID is prod db underscore stb. I'm just giving an example. On the primary, the database SID was prod db. Now you tell me, when the clients are shifted from ProdDB database to ProdDB underscore STB, would there be a problem? Your application will complain that, boss, I must supposed to connect to ProdDB, not a database with SID ProdDB underscore STB. One more issue, we cannot have different SIDs on primary and standby. We need to make sure that on primary the SID should be ProdDB. So on standby the SID should be ProdDB. Perfect. I can have same SIDs on primary and standby. But once again, new question. If I configure 3 DRs, then I have one primary, I have 3 standby servers. All of them are having SID ProdDB, ProdDB. Same thing goes with this one and this one, ProdDB, ProdDB, ProdDB. Now, how do I uniquely identify whether I am connected to the real ProdDB or am I connected to the standby ProdDB1, standby ProdDB2 or standby ProdDB3? Now, to uniquely differentiate every server in a DataGuard configuration, there is a new parameter. It is not new parameter, but maybe we have not seen this parameter earlier in the training. In DataGuard only you will see and encounter this parameter. It is known as DB unique name. This parameter will uniquely identify each database in your DataGuard environment, even though the database SIDs are same. Even though all your database SIDs are same on your primary, on all your standbys, how many standbys you will configure. So this parameter DB unique name will identify that, okay boss, this is my real production server, this is my real standby server 1, this is my real standby server 2, and this is my real standby server 3. This parameter is very important. One more question. Okay, we have never seen this parameter, then what is the default value? The DB unique name default value is always same as your database SID. DB unique name is equal to SID, which means by default if your database SID is prod DB, your DB unique name will also be prod DB until you manually change it. So what are we going to do with this DB unique name? What we will do is, we have our primary server. On primary, our database SID is ProdDB, and unique name, I'll just use UN for unique name. Unique name will also be ProdDB because this is our real production. When we configure the standby server, on the standby server, definitely the SID has to be same. Why SID has to be same? Because if you push your application from primary server to standby server, and if it is not able to find the SID as ProdDB, it will complain. Okay, so SID has to be same onto your standby server, but the unique name we will change, saying as ProdDB underscore STB. This way, whenever I want to refer to the real primary or the real production database, I will identify it by looking at the unique name. And if I want to identify the real standby database, I will look at the DB unique name of the standby database. Right, because looking at the SIDs, I cannot tell whether I am connected to the real production or real standby because all are ProdDB. So this is why this parameter is very important. Right now we are making changes on the primary server, and definitely our DB unique name will still be ProdDB. What we need to do is, we need to just check whether this parameter is set correctly or not on the primary server. Let us check it. We'll connect to SQL Plus /SSDBA. and show parameter DB unique name. We see that DB unique name is same as your database SID. We will do select name comma open underscore mode from v dollar database. We see that the database name is ProdDB and DB unique name is also by default equal to your database SID. Right. Next, change size of recovery destination. This is pretty important. We will understand why it is important in some time, but for now, just increase the size. First of all, we will check the size of DB recovery file destination, which is currently set. Show parameter recovery file destination size. It is 3882 MB, nothing but 3 GB. We'll increase this destination size. Alter system set DB recovery file destination size to 400 GB or maybe a higher value. Now let us get into this parameter and why did we increase the size of DB recovery file destination. First of all, show parameter DB recovery file. We'll just look at what is the value that is set into DB recovery file destination. So the DB recovery file destination parameter is set to our flash recovery area. Nothing but this is the area where our archives are being generated. If you check archive log list, it says use DB recovery file destination. Nothing but our flash recovery area. Now this parameter, the size, defines the amount of archive that can be put over there. Remember, even if your DB recovery file destination is having 800 GB free, as per your Oracle setting, it won't write beyond 400 GB. So this parameter will allow you to give a control from Oracle end onto the flash recovery area location. So always have a bigger value, because if this destination is full, then you will run into errors and there is a workaround that you need to follow in order to resolve the error. So it's always good to have a bigger value. 400 GB is a good value, and also we know that again and again daily archive backups will run, so the destination will be cleared again and again. And at any given point of time, definitely 400 GB of archive will not be generated immediately or at one shot from a production server. So it's a very good value. All in all, this value must be enough to accommodate your daily archive generation. You should not have a value which is lower than the amount of archive that is generated daily. Otherwise, you will run into a lot of troubles. Fine. We are done with all the changes on the production. What we need to do is we need to review all the parameters in production once again. Why? Because we are performing a data guard configuration and we do not want that we are into some issues later on. Let us start once again from the top. Let us check the archive log list, whether our production is running in archive log mode or not. We see that archiving is enabled. Great. We have to check whether the force logging is enabled or not. Let us check it. We see that force logging is enabled, right? Good. Next, standby file management. We will check this parameter. Show parameter standby file management. It is set to auto. And we have to check whether the standby log file groups are added or not. And we see that group number 11, 12, 13 and 14 are added. Fine. And we need to check remote login password file parameter. Show parameter. It is set to exclusive. Great. And we have already generated the password file. This is also done. And we need to check the DB unique name parameter. It is also set to our default ProdDB. We need to check the size, the new size of our recovery file destination, whether it is updated or not. Show parameter. It is set to 400 GB. Perfect. So all the necessary changes that are required on the production are done. These changes are important, and make sure all the changes are implemented perfectly.